Okay, so two more examples are left that we will solve today. In this one, the value of tan x is given and it's 3/4. Also, it's given that x lies between these two real numbers. That means, as an angle in radians, x lies in the third quadrant. That is, the terminal ray of x, when you place x in the standard position, is in the third quadrant. And in the third quadrant, sine and cos are both negative. Cos is negative because it's the x coordinate of the point where that terminal ray of the angle intersects this unit circle. For example, we can draw the terminal ray. An x will have its terminal ray somewhere here. So this is the point of intersection of the terminal ray with the unit circle, and both the x and y coordinates of this point are negative, and that's why sin x and cos x are both negative. Tan, however, is positive because tan is the ratio of sin and cos. So if both of them are negative, then it is positive, which you can see also. In this situation, we have to find the values of sin x divided by 2, cos x divided by 2 and tan x divided by 2. Because tan is given, we can find secant x first, and then from that we can find cos x. But cos x will be negative. And then from cos x, we will find these other trigonometric ratios of half angles. I should not perhaps say ratio, but trigonometric function values. Okay, so this is how we start. Since x lies between pi and 3 pi over 2, like that, cos x is negative. Now it's given that tan x is 3 over 4, not 3 pi, 3 divided by 4. Now, secant square x is what? 1 plus tan square x. So if you substitute the value 3 over 4, you get 9 over 16. So this is 25 over 16. That is, so this is secant square x, that means cos square x will be 16 over 25, but cos x should be negative, so cos x is minus 4 divided by 5. Okay, so now that we have found cos x, we can find say cos x over 2. How can you write cos x? Cos x over 2, say. Cos square x over 2 is 1 plus cos x divided by 2. Because you can view x as 2 times x over 2, and 1 plus cos 2 theta divided by 2 is cos square theta. So in that sense, cos square x over 2 is 1 plus cos x divided by 2. Okay. So 1 minus 4 over 5 divided by 2. So what are we going to get from this? So 5 minus 4 is going to be 1, and that means 1 divided by 5 divided by 2. So this is equal to 1 divided by 10. But now we again have to be careful. The next step is to find cos x divided by 2. That means you will take square root on both sides. But what will be the sign? So at this stage we again go back to what is given. Since pi is less than x and x is less than 3 pi over 2, so if you divide throughout by 2, what do you get? Pi divided by 2 less than x divided by 2 less than 3 pi divided by 4. And note that 3 pi divided by 4 is less than pi. Why? Because if you multiply both sides by 4, you get 3 pi less than 4 pi, which is true. So from there, you can get this inequality by dividing both sides by 4. So this angle x over 2 lies between pi over 2 and pi. That means it's in the second quadrant. In the second quadrant, cos is negative, but sine is positive. So that means now when you take square root, it will be negative. So cos x divided by 2 is minus 1 divided by square root of 10. Again, because we are in the second quadrant, so sine x divided by 2 will be positive. Right? And you can find sine x over 2 from this value itself with your usual formula. Because sine x over 2 is positive, so we do not write a minus here. It's our ordinary square root of 1 minus cos square x over 2. So if you now substitute the value of cos x over 2, in fact you have cos square x over 2 here, which is 1 over 10. That means 1 minus 1 over 10, which is 10 minus 1 divided by 10. In fact, it's square root . Okay, so you have found cos x over 2 and sin x over 2. So now it's very easy to find tan x over 2 because it's sin x over 2 divided by cos x over 2. Let me see if I really found the correct answers or I made any mistake. Minus 1 over square root of 10 is the cosine value and 3 over root 10 is the sine. Yeah. Hence, tan x over 2 is sin x over 2 divided by cos x over 2. So sin x over 2 is what? 3 divided by square root of 10 minus 1 divided by square root of 10. So this is minus 3. So these are the values. And the last one. In this we have to prove an identity. Prove that cos square x plus cos square x plus pi divided by 3 plus cos square x minus pi divided by 3 is equal to 3 divided by 2. Okay. And here also we are going to use the double angle formula. In place of cos square x, for example, we are going to write 1/2 of 1 plus cos 2x. And the similar thing we are also going to do with the other two cos squares. Let me start it there. Minus pi over 3. So let us first write the formulas and then we will combine everything. 1 plus cos 2x. So the first one is pretty easy, it's just cos square x. So from this form of the formula you can now write the ones for these other two. Plus 1 over 2, 1 plus cosine, now square is no longer there but the angle doubles, 2x plus 2 pi divided by 3. Similarly, the third one, 2x minus 2 pi divided by 3. So you can see that you are actually getting 3 divided by 2, 3 1 over 2's. That means you can guess that whatever else is there, they are going to vanish together. And they do vanish. But we have to say why. 1 over 2 times cos 2x plus cos 2x plus 2 pi over 3 plus cos 2x minus 2 pi over 3. Alright, so now just have to expand these two things. You can remember the identity for cos a plus b plus cos a minus b. But I think remembering too many identities will only confuse us. That is why I prefer to not remember those things by heart and instead instantly find them whenever I need them. Cos 2x, so I am just going to expand this one. Cos a plus b is cos a cos b minus sin a sin b. Cos 2x cos 2 pi over 3 minus sin 2x sin 2 pi over 3. Cos a minus b is cos a cos b plus sin a sin b. Cos 2x cos 2 pi over 3 plus sin 2x sin 2 pi over 3. This type of expressions may sometimes become confusing. If you find it somewhat difficult to interpret what it means, you can use brackets like this to enclose the angle if you want, but some people do not want to use too many sets of brackets. I am one of them. Okay, so for me, after sine 2 and x are appearing, so I will not interpret this as the product of sine 2 and x. No, as long as the thing just continues after sine, I will consider that entire thing as the angle. And then after that, if some other trigonometric function is there, here sine is there again, so then that sine is some other sine. That sine is not included within the angle. So with that understanding, we write like this, and this is not just my way of interpreting these things, it's a common practice. Alright, so you can see that these two terms cancel out, and here you have 2 times of this. So that means this is 3 over 2 plus 1 over 2 times cos 2x plus 2 times cos 2x cos 2 pi over 3. Now we can write 2 pi over 3 like this also, pi minus pi divided by 3. Alright, so this is 3 over 2. I think okay, hold on. Yeah, the way I wrote this 3 over 2 here, it's not exactly correct. I should have written the equality sign here, because I am going like this now. But you understand, okay? Yeah, don't do this. Again, here also some people may remember what this cos pi minus a is, what it should be, but I would like to just expand. 2 cos 2x times cos pi over 3, because there is a minus and we are expanding cosine, so it is plus sin pi over 3. Alright, so now sin pi is 0 and cos pi is minus 1. So that way we have 3 over 2 plus 1 over 2 times cos 2x plus, already we had 2 cos 2x, so let me write them first, times, and now what shall we have? This term vanishes because of sin pi. Here there is a minus 1 because of cos pi, and what is cos pi over 3? That is 1 divided by 2, but with a minus sign. Plus 1 over 2, that means we are getting cos 2x minus cos 2x, and that is why this part really is 0, and this is just 3 over 2, hence proved. So after these miscellaneous examples, we have some miscellaneous exercises that we will do next Wednesday. I mean, the entire exercise set cannot be completed in one day, but we will do as many as we can. There are quite a few of them. Well, maybe there are really not that many, but the exercises themselves are somewhat a little more complicated than whatever we have seen so far. But anyway, whatever they are, we will see them next Wednesday. And day after tomorrow, we again go back to calculus. So that's just it for tonight. So see you on Friday. Until then, this is me, Lucifer from A Mathematical Room. Have a nice night.